Hello, I'm David Melendez, and I come from Spain, and I want to present you a project that had been 5 years long, and it's called Trash Robotic Router Platform. Why call that? Because you have to reuse everything you see around you. So my philosophy is not recycle, not throw away. I am against recycling. Better than recycling is to reuse. It's the maker culture. So, one moment. Okay. So, how I began to make this? Someday I take a router, especially a Fonera router, you know, and I question me, what can I do with this router? And I search some cool stuff. So I found the drones. The drones were popular in 5 years ago. So I want to make my own drone. I have no idea how to make a drone. So I have to learn everything from scratch. Yeah. Okay. Okay. So before this robot, I make another one to practice. No? So to learn how the stuff works. So I made a rover that's called Texas Ranger, and it was made by a Link 6 router. So it was cool, but there's no fly. So I decided to make a drone. So the drone itself is kind of weird stuff, because you have to design a system that it has to sense all the motion of the router, so of the drone. To accomplish that, we need motion sensors. So I decided to use WiMotion sensors, WiMotion remotes, to do this stuff, because we back to my philosophy. Don't recycle. Don't simple reuse. I have the sensors over there, and I decide to use them. So how can I accomplish that? Well, the sensors tell me in a different way how is drone moving. So we need, firstly, a gyroscope. And the gyroscope is the wind motion, but the gyroscope tells me where the angular rate. The motion is measured by the angular rate. Gyroscope tells me how fast I'm moving in each axis. If you see, well, the idea is to show in the screen, but some technical problems. I have a Nexus tablet attached to my drone. So if I move the drone, the sensors detect the motion, but no sensor for itself is able to tell me the absolute angle of the motion respect on the ground. I need to know how it moves respect the Earth. The gyroscope tells me how fast I'm moving in each axis. This is the pitch, roll, and yaw, the course. So I need to integrate these things. I need to multiply this moving along the time. So I have to calculate the absolute angle respect the motion angle. No? So what happens is I do this again and over again. If I motion that I'm 0 degrees, I'm integrating, but when I come back to 0 degrees, this calculation has drift, accumulate an error. So I need to cancel that drift. How I accomplish that? Well, the Wimotion Plus is the gyroscope, but I need another sensor to complement that reading. I need an accelerometer. The accelerometer cancels the drift of the gyroscope. So I need to calculate. I need a filter. I need a filter that I calculate the drift, and I subtract the drift from the absolute angle. So the accelerometer tells me when I'm not moving. When I'm not moving, it cancels the drift of the gyroscope. So once I accomplish that, yeah. Okay. Thank you. I want to pass. This is the router robot, the fish robot. You can see the Link 6 router attached to a webcam and 2 microcontrollers. In that time, there was not Arduino or something, so it was kind of difficult. So this robot, when I say, this is the basic working of the drone. the drone has no moving parts except propellers. So we have to move them in different ways, at different speeds, to reach an effect, go forward or stay stabilize. So don't get scared. So this is the full stack of the drone. We have I have explained the green box. So we have a web browser. This tablet has no application, no app. This is Firefox running of the web page of the router. So it doesn't start. No.
Just 1 minute, you can...
Okay. So,
juste, j'interromps 2 secondes. On a un message à faire passer. Il y a une voiture Tesla garée sur une voie d'accès pompier. La voiture va se faire enlever dans 10 minutes. Si c'est la vôtre, allez-y maintenant. Si c'est celle de quelqu'un que vous connaissez, prévenez-le. Merci.
I haven't understood anything. So we have the router and a Wi-Fi client, so a web browser. That it's I send the data through. I can set the control through the web browser, but it's not quite properly. So we need some kind of control better, and I chose remote control and USB. This is not a fancy remote control. This is a USB attached to a router, another router that is here. And on the travel, I'm afraid that it's damaged, so I can start the drone. But I will try to explain. How we can attach the sensor to the router. The router is chosen because I already have it. I don't have to buy anything, and it's zero cost. But we need to attach the sensor to the router directly. The idea is it's to avoid any electronics. So we have to find the GPOs. It's some kind of pins on the router that they are directly attached to the CPU.
Je vous dirais que c'est...
So we found it. This is master soldering from mine. We see the serial port of the router. Any router has serial port. And some GPOs pins that are the lights, the router lights. So we can use the router lights for another purpose. Well, we have to emulate a bus that it can speak with the sensors. The sensors use quite standard bus. It's I2C bus. It's quite common in electronics, and Wimotion also use it. So we have to emulate by software this port. So we have two pins, the clock and the data, in this bus, and every 2 GPOs we can create a virtual bus to communicate with the sensors directly. So even if we haven't had a physical bus, we can emulate it every 2 pins of the router. We have to load a special kernel module that called I2C GPO. The router has to be flashed with a special firmware. Do you know OpenWRT? Many routers with that Linux distribution, and almost everything you need you have in the router. You only have to take care the total space of flash memory of the router, but it's quite small. So you have to take care not overload it.
Cette menace-là. Puis comment on gère cette menace-là?
So
Donc,
we have
je vous dirais
two ways of communication. The GPUs that we have converted to I2C, and the serial port of the router.
il y a une ligne de front qui avance, on ne sait pas où est-ce que ça va aller.
To have an emergency console terminal. So if you break the router because you have loaded wrong firmware, you can attach a special cable to recover the router throughout this port. We don't use this port for that, but we use this port to send commands. Well, we'll explain later. This is the gyroscope, the WiMotion. We have, they told us the aircraft motion that I have told the roll, pitch, and yaw, angular rate. Always is angular rate. To get the real angle, so you have to multiply with time. You read a sensor reading. So you wait a fixed time, and you read again. So you multiply the difference with that elapsed time. So you have the real angle. It's the same that you convert kilometers and kilometers per hour. It's the same. So you have drift with this calculation, and you need the WiMotion, the Wii nunchuck. The Wii nunchuck is inside like this. Well, the Chinese version. And it only has a 3-axis accelerometer and a joystick, a small joystick, and 2 buttons. To cancel the course angle, the accelerometer is not the accelerometer is not suitable. So we need, for this motion, the accelerometer has no reading. So we need a compass, but it's not mandatory. So to read the sensors, it's necessary to make a C program inside the router that read the sensor, make calculations, and set the commands to the motors. Like everything in Linux, we have to read them like a standard file, but we have to use the special command to send what address we have to read. So once we have all the readings of our sensors, we have to fashion them, to sum them up to get 2 things, the angle and the angular rate. The angular rate we have directly from gyroscope, but the real angle respect on the Earth, we have to we have to integrate and make a fusion algorithm. So the simple algorithm is like you see in this line of code. You take into account almost all of the reading from the gyroscope and a little bit from the accelerometer. This is the poor man filter. But it's not.
L'épidémie d'Ebola à des temps de guerre. Je parle de temps de guerre parce que pendant la guerre.
So we need something more complex. It's called director cosine matrix. You can find more information about that in the Kalman filter. The Kalman filter was a NASA engineer that helped to reach the moon with the Apollo, making this algorithm. No? So once we have the readings and the angular rate, the absolute angle, and the angular acceleration, we have to take into account how we can send a signal to motors. So we need an industrial control algorithm. This is called proportional integral derivative controller. It's quite weird, like you see in the slide, but in fact this is simple. You have an angle and the desired angle. I have to stay in 0 degrees, but I'm still in 10 degrees. My error is 10 degrees. So we take 10 degrees as an error. So we multiply the error with a number. What number? It's random. We have to try. So we'll try, but it's not sufficient to stabilize the aircraft because I overshot. My error decreased, but I'm overshot. I go to the other side. So I have to take into account this fact. We need the integral term. We need to take into account how much time I'm with the error. If I have an error for 3 degrees, so much time, we can correct it by this term. We take into account the error over the time. And we multiply them with another factor. What factor? We have to try again. So the other term is the derivative, and we have to take into account other thing, that how fast I'm reaching my target, my 0 degrees. If I'm moving too fast, I will overshot. So we have to take into account that term too. And we have to multiply with another term that we have to test. So we need 2 controls, one for the angular rate and another for the absolute angle. That mess of cables is the router, it's the drone itself. And you can see how we tell the motor to spin. The router sends a command through the serial port to a microcontroller. The microcontroller reads that command and sends a linear signal to the motors, to the controllers. The signal is fixed over time, so it needs to be real time. So we need to process the commands very fast and very precisely to accomplish that. The router has to be, the main program of the router has to be fixed time too, and we need a real-time schedule of the kernel. We need to say sched, that library, and get the process to be kernel priority. So we have to integrate terms in a very fixed time. So the scheduler of the Linux can mess that. So one process we can mess everything is the watchdog kernel. The watchdog tells the router where it's hung. But it doesn't matter. If the router hangs, that's the payload. It's not important because if the router hangs, the drone crashes. So we need to avoid them. So with that command, we cancel the watchdog or we compile the kernel without the watchdog. So the motors are only the few parts I have to buy because I don't have spare. And one thing is interesting of the drone, it doesn't need, in theory, any application to control because we can send the commands through web request. So we can send through Ajax, and we can send it, and the server is quite small. So the server needs to process these queries very fast. So you have to hack the web server in the code that the request called Ajax input have to be processed very fast. So we send them to a shared memory region, and it's sent to main control. The USB is that I noticed that a cable is broken. So, well. So the USB can be read throughout the JoyDev module, and you can read by binary format. It's quite simple.
5 minutes left, is that okay?
Okay. Does it see well? Well, this is quite annoying because I want to attach the USB control to the tablet. But we need a joydev.ko module. That is not loaded in any Android image. That is quite annoying that I had to recompile the Android entirely only, but a kernel module that is 1 kilobit or something, and it's annoying. So I decided to use another router, load it to Linux again, and load the module in the router, because I don't want to recompile an Android entirely. So in one event a year ago, where I was speaking at the conference in Spain, a troll switched on the air crack and the air dump. So they send to the router the authentication packets. So any drone with Wi-Fi can be hacked throughout this kind of attack. You have no control if somebody sends you the authentication packet. So I decided to make my own Wi-Fi protocol. You can see the control enters in a monitor mode, and it sends the commands through beacon frames. I have to make a force packet with beacon frames and inject them throughout the Wi-Fi. But if I inject the packets in plain text, I am vulnerable to the other attack. So you can take the packet and resend it. So we need to encrypt that packet to avoid reinjection. So we have to encrypt with a key that is pre-shared through the normal Wi-Fi protocol, and it enters in a monitor mode. So all the commands I want to send are encrypted with this key. We have the header. If you turn on your laptops, you will see two networks. Atropos network and Atrop. The Atropos network is the normal network. It's the standard network, and it's pre-shared key. It's normal. It's the way that telemetry returns to the tablet. But the control is with another system. The router sends forged beacon frames, and you can disassociate the station because it's not associated. Well, the demonstration, I'm afraid, is not possible because a cable is broken during the trip. So if you want to see the drone flying, we can make later on the batch stage, or you come to ask me, and I will try. But you can see in the internet. Is the internet?
I'm not sure you will have internet for now, and your time talk is over.
Okay. So we have no more time, so thank you very much. If any question?